Hello everyone, my name is Samir Kumar Singh and I welcome you to Week 6 tutorial. Uh, in this week, we will take the questions of the from lecture 24 to 29. Uh, so it will help you out to solve the assignment of the week 6. Okay. This question number one is on your screen. You can try. The question is that which of the following is an important criteria for a good wireless communication system? You have four options. You can comment or you guys can speak. So guys, question number one is that which of the following is an important criteria for a good wireless communication system? Option are robustness to multipath fading and interference. B is the spectral efficiency. C is the power amplifier efficiency. D is the all of the above. Guys, try these questions and you can comment your answer. Okay. So the right answer of this question is the all of the above because this all parameter very important to make a good wireless communication system. Okay. The answer will be D part. So anyone have a doubt can ask. Okay, question number two is given there. This question is the PDF of Russian distribution with four different price factor is plotted below. Which one of them is the smallest? There we have a plot that is a draw between the PDF and amplitude of random variable D is given. In x-axis, amplitude of a random variable is plotted, and the y-axis PDF of a random variable is plotted. And there we vary the k or we can say rise factors. You have to tell which have the smallest value. There are four options: k1, k2, k3, k4. So take your time and you can comment your answer. Okay, basically Russian distribution is represent to LOS component. Whenever we have the line of sight environment to represent this, we are using the Russian distribution. It was this the PDF was designed with the parameter k. That is called rise factor. Okay, so there are four plots. So which one of the smallest? K1 have the smallest. So option A is the right option. So for the question number two, as option is right and K1 is the right option. Okay. Okay. Question number three is that which is the order of the BER in relay fading channel, or assuming that a same average SNR. So we have to calculate the BER for the relay channel. The channel is given the relay fading channel, and the modulation schemes are the BPSK, GMSK, and DPPSK. So you have to tell which option is the correct, which have the arrange in terms of BER, decreasing order, increasing order. Calculate the BER. Just write the formula of the BR. From there you can compare which option is the correct. The condition is given that assuming the same average SNR. SNR is the same for all the streams. Try it. There are three types of modulation schemes: are BPSK, GMSK, and DPPSK. Just revise the formula of the BER. Channel is given relay feeding. If anyone got the answer, can comment. Sorry. So, okay, the option is also right for this question. Sorry, option is right. Basically, we just have to put the value of SNR. There are these three: the BPSK, GMSK, and DPPSK. So we get the highest BER in DPPSK and the lowest in the BPSK. So option is right. Next question is numerical question, and the data is the same for the question number 4 and 5. Question number 4 is okay. Firstly, we read the data. A radio system is usually specified in such way that a receiver should be able to handle a certain amount of a Doppler spread in the receiver's receive signal without losing too much performance. Assume that only receiver is moving and the maximum Doppler spread is measured at twice the maximum Doppler set. Further, assume that you are designing a mobile communication system that should be able to operate both 9 MHz, 900 MHz, and 1800 MHz. Just read the data. And the question number 4 is that if you aim at making a system capable of communicating when a terminal is moving at 150 km per hour, what maximum Doppler spread should it be to handle? Okay, try this question for your make it is the I just hint I'm giving the I just write the formula of Doppler spread is given there. By your intuition, you can apply there, right? Apply there. And let me know which option is the correct. Again, I'm reading the question. Question is that if you aim at making the system capable of communicating when a terminal is moving at 150 km per hour, what maximal Doppler spread should be able to handle? So V is given. To calculate Doppler spread, we have to know FC, V, and C. So V is the 150 km per hour. C, you know that, and to get the value of FC and try to calculate Doppler spread. Please try it. Okay. Now we'll see the answer of the question. Okay. So maximum Doppler shift occur at 18 megahertz. Basically, two frequencies given: 9 megahertz, 900 megahertz, and 1800 megahertz. So maximum Doppler you will get at 1800 megahertz. So you have to calculate Doppler spread. FC, V, and C is given. Okay, FC is the 1800 megahertz. Okay, V is given then 150 km per hour. So you can convert in a meter per second. And C is the 3 into 10 to 8. Just do the mathematics, and from there you will get it will come 500 megahertz. So again I am explaining explain this answer. FC is given 1800 megahertz, V is the 150 km per hour, convert in a meter per second, and C is given 3 into 10 power 8. So just put the value, and from there you will get the maximum. You will get the Doppler spread is the 500 hertz. So option B is the right. Okay. Question number 5 is it's also based on the data. The data is same for the 4 and 5 are same. So here is they are asking if you design the system to able to operate at 150 km per hour when using the 900 megahertz, at what maximal speed can you communicate at 18 megahertz? So here they are telling if you design a system to able to operate 150 km per hour when using the 900 megahertz. Okay, V is given 150 km per hour when you are using the 900 megahertz. So you have to find what maximal speed can you communicate if the 1800 megahertz band is used. So firstly, using the given value 150 km per hour and 900, from there you can get Doppler spread, and after that you can calculate the maximum speed for the 1800 megahertz. So guys, try it. Firstly, try to find the value of the Doppler spread for the 900 megahertz. Okay, so as I tell you, firstly calculate the Doppler spread for the 900 megahertz by using that. So by using this, you can get your maximum speed. So okay, if system is designed for the 900 megahertz, the maximal allowable Doppler speed is given is 900 megahertz. FC, you know. So so from there you can get your FC. Okay, sorry. Here Doppler spread is given 900 megahertz and speed is 150 kilometer per hour. From there you can calculate FC, and after that you can calculate the maximal speed for the 1800 megahertz band. So, the explanation is given there. If the system is designed for the 900 megahertz, the maximum allowable Doppler speed is 2 FC into FP by C. From there you will get 2 by 250 hertz. So if this has to work with 1800 megahertz, so just put the value of Doppler spread 250, and from FC is given. From there you can calculate the maximum speed. So Tmax will come to 75 km per hour. Okay, the answer will be the B part. You can observe that for the 900 megahertz you are getting the 150 km per hour. As you rise the speed, as you rise the frequency 80 megahertz, your will become speed is reduced and it comes 75 km per hour. Question number 6 is given. Question number 6 is that let the probability of error in AWGN for a particular modulation type is as speed AWGN is 5 e is to minus 2 gamma, where gamma is the instantaneous SNR. What will be the probability of error in relay fading channel with the average SNR? So, let, again I am repeating this question. Let the probability of error in AWGN for a particular modulation type is AWGN is 5 e is to minus 2 gamma, where gamma is the instantaneous SNR. What will be the probability of error in relay fading channel with the average SNR? The average SNR is given as a hint. I am giving that. Convert in a linear scale, and from there you will convert a VER, because this formula is already derived for the relay fading channel. For that, try this. Let me know which option is correct. If anyone got the answer, can comment. Okay, yes, the solution. Firstly, convert gamma in the linear scale. Here, gamma in the dB is the 12 dB. From converting in linear scale, it will come around 15 point something. So just put the value of the gamma, and it will come 0.15. So option D is the right answer. Okay. Question number 7 to 10 all are the link question. So there is a table is given. first row is we are written the delay, and the second row represent the power, that is in dV. Question is that the power delay profile for a channel is defined below. Okay, so we have to calculate the mean delay in microsecond. So first question is that calculate the mean delay. Okay, table is given. First row represent a delay, second row represent the power, that is given in dV. Calculate the mean delay in microsecond. So guys, try this. From 7 to 10, all question are links. If you get the value of the mean delay, by using that we can solve the further upcoming questions. So please try and let me know which is the right answer, which option is correct. Okay, so here we converted the power in the linear scale by using a dV converter. Okay, so it will look like that. So we have to calculate the mean delay. We just multiply the delay with the power, and this part is the summation of the power. So after doing the mathematics, you will get your mean delay, and it will come 2.31 microsecond. Explanation is simple. Tau is the this column, this row, and it is a power, that is a linear scale. Just multiply them and usually multiply them and do the summation. Firstly 1 into 0, 3 into 0.5, 5 into 2.5, 7 into 1.0, 7 into 0.126. Similarly, and multiply the n with the 0.0063, and last multiply the 11 with the 0.032, and do the summation. That will comes in the numerator part. Similarly for denominator, just simply add them, and after solving you will get it will come 2.31 microsecond. So its option C is the right. Okay, similarly next we have to calculate RMS delay spread in a microsecond. So just try, just use the formula, the RMS delay spread. Data is the same. Okay, here we have to calculate RMS delay spread. Okay, so formula of RMS delay is given here. Tau is replaced by the tau square. Just multiply them individually, and after that add them, and next divide with the summation of this, divide with the this row. So your time constant, I just write a value. So it will become something 25.899 into 10 raised to minus 12. Initially it's coming 10 to power minus 6, but here we are using the tau square. It will become tau 10 raised to, it will become minus 12. Okay, and the summation of this will remain same. It will come 1.971. From there first we calculate tau square, and it will come 13.14 into 10 to minus 12. Okay, so now we have to calculate the RMS delay spread. Okay, so over here tau square is given 13.14 into 10 to minus 12, and tau is already calculated in the last question. It was mean delay was the 2.391. It was 2.31 and it was 13.14. Just put the value, it will come 2.8 microsecond. It's so our RMS delay spread is the 2.8 microsecond. Okay, so your option is the right. Okay, if anybody have doubt can ask. Okay, question number 9. Okay, the data is the same. Question is, and they are asking about to calculate the minimum coherence bandwidth in the kilohertz. So here we have to calculate minimum coherence bandwidth. In last two questions we have calculated the RMS delay spread and mean delay. Question number 9 we have to calculate the minimum coherence bandwidth in the kilohertz. So I apply the formula and the concept of the coherence bandwidth. It should become in the kilohertz. Okay. Okay. Now we see the solution of this question. We have to calculate the minimum coherence bandwidth. Okay. So minimum coherence bandwidth, the condition is given that it should be greater than equal to 1 upon 5 sigma tau. So by using the data of the last question, we have calculated sigma tau. It's the RMS delay spread. So just put the value 5 into 2.8 into 10 raised to minus 6. After calculating, it will come 71.43 kilohertz. So the coherence bandwidth is the 71.43. It is the condition for the coherence. Get the minimum to calculate the minimum coherence bandwidth. Okay. The answer is the 71.43. Last question also is related with the previous data. Question is that for which of the following symbol rate is an equalizer required? Which question is that for which of the following symbol rate is an equalizer required? Guys, please try this question. Okay. So an equalizer is required when sigma tau is greater than Ts by 10, or equivalently Rs is equal to 1 upon Ts. It's greater, and it should be greater than 1 upon 10 times of sigma tau. So we already know the value of the sigma tau. From there we can get, it will come at 30.35.71 kilohertz. So our option is that 45.4, 30.1k, 13.4k. So only 30.1 is close to that, 35. So option is the right. So we have required for the equalizer for the 30.1k symbols per second. Equalizer required for the decimals, semi-decimal rate. Okay. Next question is what does the term doubly selective channel imply? Basically we have 4 conditions: time varying, frequency selective channel. So we have 4 options: time varying, frequency flat channel, time flat, frequency flat channel, time flat, frequency selective channel. Guys, let me know which option is the right. What does term doubly selective channel imply? So option is the doubly selective channel is basically time varying frequency selective channel. So it will be time varying, and it should be time varying and frequency selective. So option A is the right. It is the time varying and frequency selective channel. Next question 12 is given that question is the consider a channel with a coherence time which is given 0.12 millisecond and the coherence bandwidth is 35 kilohertz. So what would be the channel appear to signal with a bandwidth of the 14 kilohertz and a symbol rate of the 1k symbols per second? Data is given. We have to tell which option is the right. So by using this data, we can comment our channel frequency selective or frequency flat. We are calling it fast fading or slow fading. So we have the coherence time and the coherence bandwidth. So guys, please let me know which is the right. Okay, by using this data, we can comment which option is the right. Okay, so given is that coherence time is the 0.12 millisecond and coherence bandwidth is 35 kilohertz. How would the channel appear to signal with a bandwidth of the 40 kilohertz and a symbol rate of the 1k symbols per second? Okay. Okay, signal bandwidth is greater than coherence bandwidth. Okay, signal bandwidth is given the 40 kilohertz, and the coherence bandwidth is at 35 kilohertz. Whenever signal bandwidth is greater than coherence bandwidth, the channel is the frequency selective. Okay, so frequency selective is the first two option may be right. We can cut the option C and D because channel bandwidth is the greater than the coherence bandwidth. Okay, next we will see the sum. Okay, next symbol period Ts is equal to 1 upon 100 second, so it will come 1 millisecond. Okay, symbol period is coming 1 millisecond and coherence time is given that 0.12 millisecond. So coherence time is given 0.12 millisecond and symbol period is give 1 second 1 millisecond. So here single symbol time is a greater than the coherence time. The channel is the following the fast fading. Okay, so option sorry. Okay, so one option is the right. So it will be frequency selective due to channel bandwidth is greater than the coherence bandwidth. And next we calculated the coherence. We compare the coherence time with the symbol period, and it's coming the following the fast fading channel. Option A is the right. Okay. Next four question also using the same data. Question 13 is that a user is moving at 100 km per hour at the base station to is communicating with the user through the GSM network at a frequency of 2.7 gigahertz. Okay. Again, I'm reading. It says user is moving at a 100 km per hour and the base station is communicating with the user through the GSM network at the frequency 2.7 gigahertz. Okay. Next question is what is question? Question is that using the definition of the coherence time as the time duration for the which channel correlation drop to 1 upon root 2 of the initial value, which is the initially 1 and next is the drop. Find the coherence time of that channel. Correlation is dropped from 1 to 1 upon root 2. So then we have to calculate the coherence time of the channel. And data is given. V is the 100 km per hour and frequency is given the 2.7 kilohertz. Sorry, gigahertz. For this, you have to calculate the coherence time of the channel. Guys, please let me know this is the right. If anyone got the answer, can comment. Okay. Next we see the explanation of this question. Okay. So firstly, we calculate the FD. FC is given 5.7 gigahertz. V is already given. C is given 3. C is the 3.10 power rate. From there, we are getting the FD. FD is coming at 250 hertz. Okay. So we have to calculate the coherence time. Okay. we have the FD, and from by using the formula of the TC is equal to 9 upon 16 pi FD. The FD is given 250 hertz. It's coming 716.2 microsecond. 716.2 microsecond. So option is the right. Okay. Firstly calculate Doppler frequency and apply the coherence time formula. From there we can calculate the coherence time. Okay. Next question also related to the previous data. Question is that find the approximate spectral binding at the receiver assuming a single tap relay feeding channel. Again, okay, question is that each user is moving at 100 km per hour at the base station, and the base station is communicating with the user through a GSM network at a frequency of 2.7 GHz. Find the approximate spectral binding at the receiver assuming a single tap relay feeding channel. Guys, try it. Spectral binding. Okay. Spectral binding is just 2 times of the FD. And in last question we calculated already Doppler frequency. It's coming the 250 hertz. It's just multiplication of the 2 to 250 hertz. It will become 500 megahertz. So option B is the right answer, because all questions are related. We are using same data. So in question number 13 we calculate the coherence time by getting the Doppler frequency. Next we are calculating spectral binding. And now question number 15 they are asking. Question number 15 is it is decided to incorporate frequency hopping in the system. Okay. Find it is a find that hop rate to avoid fades. Assume there is at least one good channel at any instant in time. We have to calculate where to find the hop rate to avoid the fades. Assume that there is at least one good channel at any instant in time. Data is the same. Find the hop rate. But just use the formulas that are explained in these concepts. Initially GSM, basically in GSM we are preferred frequency hopping, but here they are trying to incorporate frequency hopping. So we have to calculate the hop rate to avoid the fades, or a condition is given that assume that there are at least one good channel at any instant of time. Okay, we have to calculate the hop rate. Okay, and the hop rate is equal to 1 upon coherence time, and TC is already calculated in the question number 1. Okay, it's coming 716.2 microsecond. So from there we can calculate our hop rate. It will come 1396.26 hops per second. So we ignore this term and it will come 1396 hops per second. So option is the right, just inversely proportional to the coherence time. Okay, question number 16 is if Vrms is set as the threshold, then find the maximum number of the fades per second that can occur. Now we set the threshold at the Vrms, so we have to find the maximum number of the fades per second. Here we set the threshold. So from the options you can understand here number of the fades are decreases, because we have set the Vrms to comparatively lower. So guys, try it. Data is the same. Again we have to calculate find the number of the fades per second. Okay, so threshold here we about threshold value is the V is equal to the VRMS. So we can calculate the rho, and it will come a VT upon VRMS, and will equal to 1 into NV number of the fades per second. It's will equal to the under root 2 pi FD rho into E minus the rho square. So from there it is coming a rho is the 1. Just put the value of FD and the rho. Just put all this value in the calculator. But FD is already calculated in the question number 13. Rho is the 1. Just simply put the values and it will come to 31. So D option is the right. Okay, if anyone have doubt can ask. Okay, next question is that if VRS is set as the threshold and find the expected fade duration. Now question is change. Here we have to tell what is the find the expected fade duration. Initially we are last question we calculate number of fades, and here we have to calculate fades per fades expected fade duration. Last question we are getting the 231 after setting the VT is equal to RVRMS. Here we have to calculate the expected fade duration. Okay, try this question. Okay, so T fade is equal to the for this scenario it will be E rho square minus 1 upon 2 pi FD rho. Rho initial and last question rho is the 1, T is the 250. Just put the value, it will come 2.74 milliseconds. The answer will be the D part. Okay, thank you.